Hi, in this session we will consider the second problem, and here we have a sphere of diameter 50 mm and it is centrally placed over a cylindrical slab of 60 mm diameter and 20 mm height, and here we have to draw the isometric projection. That means we have to take isometric scale. First of all, you have to draw the simple plan and elevation. Here the bottom portion is cylindrical, so you have to draw the circular portion of the base, and that is A, B, C, D, and the top points are E, F, G and H. In this condition, we can consider only 4 equal divisions. Project upwards and obtain the corresponding view of the cylindrical base. This is A dash, B dash, C dash and D dash, E dash, F dash, G dash and H dash. That denotes the cylindrical slab. And the sphere is centrally placed over the slab. So for that you have to locate the center of the cylinder and you have to draw a vertical projector. And from this intersection, this line will intersect the top surface of the slab at this position, and take radius equal to 25 mm, because the diameter of the sphere is 50 mm. So this distance must be 25 mm, and mark the position of O dash, that is the center of the sphere. After that, draw a circle that will give the sphere. After that, you can keep the same radius in your compass, and with O as center, you can draw the inner circle which denotes the periphery of the sphere. After that, you have to enclose the cylinder in a square cage, and that square cage is denoted as 1, 2, 3, 4 and 5, 6, 7 and 8. Then here you have to draw the isometric projection. You have to take isometric scale and we will mark point 1 here, point 1. Then from point 1 you will draw two 30-degree lines. This is 30 degree and this is also 30 degree lines. And mark the isometric equivalent of 60 mm. 60 mm is the diameter. So 60 multiplied by 0.816 give 49 mm. So 49 mm is marked on this line and on this line. And that points are point 1 and 2, and here we have point 4. Then draw another 30-degree line in the opposite direction and it will intersect here, and that is point 3. After that, project upwards, projecting vertical lines from 1, 2, 3 and 4, and marking the isometric equivalent of this height. This is 20 mm. 20 multiplied by 0.816 gives around 16 mm. That 16 mm is marked on this vertical lines, so that you will get the position of point 5, 6, 7 and 8. So we have completed the isometric projection of the outer cage. Now we have to locate the inner points. For that, you have to mark the midpoint of these edges. The total length is 49 mm. So 49 divided by 2 gives 24.5 mm. So mark that distance is the midpoint. That is, I should have to mark the midpoint 24.5 this side. Another 24.5 here. Another 24.5 here. Similarly, on the top surface, 24.5, 24.5, here and here. I have to mark one more. That's here. Then, after marking the midpoints, we will be connecting these points with the opposite corner. Connect this one. These lines must be thin lines. First, we will consider the base points. Connecting with one with the point, the midpoint of line 3, 4 and 2, 3. So that we will get these two lines. Similarly, point 3 with the point located on 1, 4 and 1, 2. So that we will get an intersection here and here. Let us take the compass and with 1 as center and radius equal to this one, I'm drawing an arc up to this position. You can keep the same radius in your compass and you can draw another arc up to this point. So, we got two arcs. Now, keep this radius in your compass and draw another arc. Keep this radius in your compass and complete that. So that we got the base portion of our cylindrical object, cylindrical slab. We have to repeat the process in the top portion also. We have to connect 5 and the midpoint of 7 and 8. 5 with the midpoint of 6 and 7. 7 with the midpoint of 5 and 8, that is here. 7 with the midpoint of 5 and 6. So that we will get the intersections here and here. Let us take the compass and take radius. Take this radius in your compass. Let us draw an arc. The first arc, keeping the same radius with the 7 as center, let us complete that. This arc. And take this radius in your compass and draw another arc here and another arc here. And after that you have to draw a vertical line which is tangential to these two ellipses. Draw two vertical lines which are tangential to the ellipses that you have drawn. And this portion is the top surface and this portion is the base. This curved portion is hidden behind the object and that should be dotted. We will consider it later. Then after that we have to fix the sphere over the object. And for drawing that, first of all let us find the center of the cylinder, because the object is centrally placed. So we have to locate the center of the object. We will connect the diagonal and locate the center. So this is the center of the top surface. And for drawing the isometric projection of a sphere, you have to follow some specific steps. Here we have to draw the isometric projection of a sphere. For drawing the isometric projection of a sphere, first of all we have to locate the point of contact. This is the point of contact. After that you have to take the isometric equivalent of its radius. The radius of this sphere is 25 mm. So 25 multiplied by 0.816 will give, let us calculate, 25 multiplied by 0.816 gives around 20.4, around 20.5 mm. 20.5 mm. This the isometric equivalent of this radius is 20.5 mm. Isometric equivalent. Actual radius is 25 mm. 25 multiplied by 0.816 gives approximately 20.5 mm. Take that distance in your compass and we have to mark 20.5. Take 20.5 in your compass. And this is the point of contact or the center of the top surface. With 20.5 as radius, you are drawing an arc. And that will be the position of point O. That is the center of the sphere. And for drawing the outer surface of the sphere, you have to take the actual radius in your compass, that is 25 mm. Take 25 mm in your compass. The 25 mm is the actual radius, and you have to take that distance in your compass. It's 25 mm. Take 25 mm in your compass, and with this point as center, you have to draw a circle like this. I have some complaint with my compass. So that you will get a circle like this. and that is the isometric view of this cube, the cube which is resting on the cylindrical object. So I am repeating the process. For drawing the isometric projection of a sphere, first of all we have to locate the point of contact. That means the center of the top cylinder. This is the center. After that, you have to take the isometric equivalent of the radius. The isometric equivalent of the sphere is 25 multiplied by 0.816 gives around 20.5 mm. Take that distance, that is 20.5 mm in your compass, and you have to mark this distance. This is 20.5. That is the isometric equivalent of the radius, and that is the center of the sphere. After locating the center, take the actual radius. Very important. Take the actual radius in your compass, and the actual radius is 25 mm. Take 25 mm in your compass and draw a circle, and that is the outer profile of the sphere. So that is the steps that you have to follow. That are the steps that you have to follow for drawing the isometric projection of a sphere. Now suppose that it is isometric view. If it is isometric view, then for marking the center of the sphere, you have to take the actual radius. So if it is isometric view, then for marking the position of point O, you have to take the actual radius if it is isometric view. So mark 25 mm, and that is the center. After that, you take the radius, and for taking the radius, the outer profile, you have to take this radius, that is capital R, and that dimension is the actual dimension, that is 25 divided by 0.816. That is 25 divided by 0.816 will give 30.6. 30.6. So, for drawing isometric view, mark the actual radius and locate the center. Then, for drawing the circle, you have to take radius equal to 25 divided by 0.816. That is around 30.6. And with O as center, you have to draw that circle. And that is very important. In case of isometric projection, center is the scaled radius, and profile radius is the actual radius. For isometric view, center, for marking the center, you have to mark the actual radius, and for drawing the profile, you have to calculate the radius is equal to the actual radius divided by the isometric scale, that is 0.816. That will give the profile radius. And in isometric view, the profile radius will be greater than the actual radius. And these are the steps that you have to follow while drawing the isometric view and isometric projection of a sphere. That is very important. We will consider the isometric view of a hemisphere in the next class. Thank you.